Okay, we're going to be seeing how to do Stoich problems when you're going from moles to grams or grams to moles. So here we have our starting balance equation that you'll need for doing a T-chart when you're doing a Stoich problem. Alright, so here, how many moles of SO2, sulfur dioxide, that's our unknown, are needed to react completely with 7.2 grams of carbon? So that is your given. Okay, so we're going to set up our T-chart, and we're always going to put the given in the top left, 7.25 grams of carbon. So make sure you're putting the unit, like grams, and the substance carbon. Put units and substances in the T-chart as you work through it. Right away, let's put what we're trying to get to at the end, because that's going to help us know we're going the right direction, and you always get a point for like a test or quiz for labeling your answer correctly. Okay, so right now what we can do is we can reference the heart of Stoich that helps us figure out what we're going to need to do here. So we're given grams and we're going to moles. So using this, we are given the mass, the grams, and we are trying to find the moles of our unknown substance. So we're going to go from grams of our given, like substance A here, and unknown, we're looking for the moles. So this is going to be 2 steps here. So our first step is to figure out the molar mass of our substance, put that on the bottom to cancel out the grams on top, and then put 1 mole on the top. This is your molar mass step. Okay, so we have grams of carbon on the top, we want to cancel it out, put grams of carbon on the bottom, which we'll look up in a bit, and that we're going to do for every 1 mole of carbon. So we're going to do the molar mass. So for carbon, the grams of carbon, here we see the molar mass is 12. Okay, so for every 12 grams of carbon, we have 1 mole of carbon. So now we're in the unit moles of carbon. We want to get to moles of SO2, sulfur dioxide. So we want to cancel out the moles of carbon. So here we see it on top. We're going to want to put it on the bottom. But to see that on here, we're in mole of carbon. We want to get to mole of SO2. So this is your mole ratio step using the coefficients from the balanced equation. Okay, so if I have 1 mole carbon on top, I want to put mole of carbon to cancel it out. And I see I have a 5 in the balanced equation. I have 5 moles of carbon. And in my reaction here, for every 5 moles of carbon, it's going to react with 2 moles of SO2, sulfur dioxide. Mole of carbon cancels out. I'm in mole of SO2, sulfur dioxide, which matches my endpoint here. So now we're going to multiply the top numbers. So 7.25 times 2. And then we're going to divide by the numbers on the bottom. So divide by 12 and then divide by 5. Enter. So we get 0.242 moles of SO2. Okay, let's do one more. Alright, so same reaction, but different starting points, ending points. How many grams of CS2? That's your unknown. And you're given 6.3 moles of carbon. Okay, so again, we're going to put the given in the top left. 6.3, I'm putting the unit mole and the substance carbon. That's important. And then I'm putting what I want to get to at the end right away. So I want to go to grams, and I want to go to CS2. So again, you get a point right away for tests and quizzes by doing that. So to kind of map this out on the heart of Stoich, I'm going from mole, I'm starting with mole, and I'm going to grams. So on the given side, I'm starting at mole, and then my unknown side, I am going to grams. So this is going to be 2 steps here. Okay. So the first step is to use the mole ratio step to go from moles of carbon to moles of CS2. Alright, so since I have moles of carbon on top, I need to put moles of carbon on the bottom to cancel it out. And I'm going to put mole of my new substance, CS2, on top. Looking at the balanced equation, for every 5 moles of carbon, I have 1 mole of CS2. So I'm going to put 1 on the top here. Okay, moles of carbon cancels out. Now I'm in mole of CS2. I'm not matching my unit yet, grams of CS2, so it means I have one more step left. So right now, we're on the unknown side, we're in moles of CS2, we need to get to grams of CS2. So we're going to do our molar mass step. For every 1 mole on the bottom, we're going to put the molar mass of carbon disulfide CS2 on top. So we're going to cancel out the moles and put that on the bottom. And I see that I'm going to have 1 mole on the bottom based on my conversion factor. And we're going to do the grams on top. Grams CS2. Here we have a compound, so this is where we have to split up the elements. So we have carbon and we have sulfur. I have 1 carbon, I have 2 sulfurs. Now we're going to get the masses off the periodic table. So carbon has a mass of 12, sulfur has a mass of 32. So 12, 32, that's 12, that is 64, so that would be 76. So there are 76 grams of carbon disulfide in every mole of it. So the moles cancel out. I'm left in grams, which is what I want. So I'm going to do my math here. Multiply the top numbers, 6.3 times 76. Press enter, and then divide by anything on the bottom. So I don't have to worry about the 1, but we're going to divide by 5. Enter. So we get 95.8. We'll round that 7 to an 8. So 95.8 grams of CS2 for every 6.3 moles of carbon. Okay,